Okay, thank you very much for joining me this morning. My talk's called IAM is Your Friend, and IAM, as most of you will probably know, stands for Identity and Access Management. Now, why do a whole talk just on IAM out of all the services within Amazon? The thing about IAM is it's everywhere. Every single service that you use uses IAM. Every single time you go into a new service or you use something for the first time, chances are you have to go into IAM, add some permissions or some new policies to your role. So it's everywhere. So being familiar with IAM really can benefit you no matter what side, what aspect of AWS you use. It's also free. If you think about it, every single service in Amazon costs money, mostly, right? But IAM is free. As far as I know, there's no way you can use it too much or actually end up paying money for it. So that's yet another reason to really become familiar with it and to leverage it as much as you can. Now, IAM has been around for a very long time, and we're going to see the next slide is going to kind of go back a bit to where IAM came from. Because of that legacy, a lot of the tutorials you read and a lot of the information online approaches IAM in a way that maybe isn't so helpful for a kind of modern serverless environment. So there are lots and lots of cool things that you can do with IAM and lots of ways you can get benefits from really focusing on it. I'm going to concentrate on an example of a serverless environment because that's where a lot of us work in nowadays. So a lot of people, IAM can be an annoyance. It can be that sort of thing, you're going through a tutorial, you're trying to get to the good stuff, you're trying to get whatever service it is you're building out working, and you get a complaint because the permissions aren't set up right. So you go in and you find some blueprint or you find some policy that, you just keep adding policies to a role and eventually it works. And you're like, right, fine, I can forget about that now. So I'm going to show you in this talk some step-by-step techniques that we use at Fraction 7, a pattern, if you will, that we follow and that we find is a completely different approach to IAM and that for us works really, really well and we get lots of benefits from it. One of the things I hope that you'll take away from this presentation, even if you, two things I wish you would take away. One is just a different perspective on IAM. It's not just this boring service that you kind of have to get out of the way. But also that whenever you see any other presentation about AWS today or anywhere else, that, like me, you will look at those diagrams, you will look at the service and think, okay, if I'm going to roll this out, how am I going to use IAM? How is IAM going to help me to really make the most of the service? Okay, so if we go back a few years, if you picked any slide from reInvent 2012 or 2011, and you picked any presentation random, there would probably be a diagram that looks a little bit like this. We have an EC2 instance or many EC2 instances. You might have an S3 bucket. You might have a database, maybe an API gateway. And in this kind of scenario, all of our business logic is locked away inside that EC2 instance. And so that EC2 instance is going to have to do quite a lot of things with the database and with the S3 bucket. It's probably going to have to write to it, read from it, scan the database maybe, query the database, list items in the S3 bucket. And so because all of our business logic is kind of locked away and in that EC2 instance and it's just accessing resources, in this kind of context, IAM is all about resources and permissions. It's all about who is allowed to get access to what. It's all about managing, let's make sure this employee doesn't kind of accidentally go and delete a database, or let's make sure that hackers can't kind of get in through the API gateway and do things they shouldn't be. It's all about locking things down. And so the upshot of this is that, if I can click here, what we end up with, so this is a policy they actually grabbed from AWS itself. We end up with policies like this. Now, if any of you have used IAM, and if you've used AWS, then you will have used IAM. You've probably come across policies. You might not have logged into the JSON that defines it, but these are the examples that you see a lot, and even the AWS blueprints will show you, will set up policies for it look like this with lots of permissions in. There's all kinds of configuration. And it makes sense that the policy has to be this complicated because it has to sort of map to everything that EC2 instance might want to do with the database. And of course, this is a pain to maintain. No one wants to look at that. And so one of the things that doesn't help either is that a lot of the tutorials will tell you, hey, set up a role, set up a role for your EC2 instance with all the permissions it needs, or your service. And so, of course, you finally get your role kind of put together, it all works, and then you're going to reuse that, because that's almost what people encourage you to do. But that's not ideal either, because then you just end up with a role which is my server talking to my database role. And so you reuse that again and again and again. Over time, more and more permissions get added in there. And at the end of the day, that policy becomes almost meaningless. It just becomes this permission fest, as it were. But now if we look, nowadays, okay, if we look, say, in 2018 or 2019, if you see presentations at reInvent, or maybe even today, you'll much more likely to see diagrams maybe that look like this, where all the logic that was inside that EC2 instance before has now been exploded out into this family of services where we have lots of lambdas there, we have all kinds of AWS services all interacting in all these complex kind of ways. Now, whenever you see a diagram like this in any presentation, think about all those lines connecting microservices. Every single one of those is governed by IAM. There will be an IAM policy that has to be enforced. IAM will be policing every connection between every microservice. And what we begin to see is a new way of using IAM, a new way of using account management and identities, because now it's no longer about, can this server talk to this database? And it's much more about, can this function, maybe this machine learning service or this Lambda function that does something very specific, can we really narrow down what specific things that service needs to do? So one of these Lambda functions, maybe all it needs to do from the database is get an item from the database. Maybe another Lambda, maybe it needs to just write things to the database. So now suddenly, IAM becomes the thing that binds together all of our microservices in this way. Another thing to consider is with these, and if any of you, I know this is the intro track, but I can guarantee as soon as some of you, even if you're just starting out with AWS, as soon as you start really exploring some of the things AWS has to offer, you're going to end up with something like this pretty soon. And that can be quite hard to control and keep track of, especially if you're a bootstrap startup or you're a small business. So this kind of leads us to a new way of thinking. So kind of 5 years ago, and a lot of the documentation and tutorials you'll see kind of are set in that setting of 5 years ago. We had a server resource architecture. It was in the cloud, but it was still really a server accessing resources. It was all about regulating access to those resources, IAM was. And so it's almost like an InfoSec concern. Like there's this person in your business, it's their job to kind of write these policies. It's their job to manage all this complexity. Now in 2019, however, AWS is much more, especially in a serverless world, it's much more about microservices interacting in complex ways. IAM becomes much more about enforcing contracts between those microservices, and I'll show you an example of that in a few slides. And so now it's much more of a software design concern. And again, I'll illustrate what I mean by that. I just got one more slide like this to kind of compare how we can think about IAM. We used to have these broad, very complex policies, like I showed a few slides ago. But now, I advocate tiny single action policies. Instead of reusing roles, I advocate having just one unique role for every single microservice. Just make a new role. Instead of starting off with these blueprints, like the AWS tutorials encourage you to do to get you off the ground running, I say start with a blank canvas. Start with a blank IAM policy every single time you create a new microservice. And that might seem like a lot of work. That might seem like, hang on a minute, I'm not reusing roles anymore, am I creating unique roles? And instead of me kind of, okay, I have to work a bit harder to write this one policy, but at least I can use it. Instead now I have to make lots of policies. And instead of starting off the blueprints so I can get off the ground running, instead, I have to start with a blank canvas every time. And that sounds like that's a lot of work. So I'm going to hopefully convince you that that's not the case. Okay, so I'm going to go through an example here. I'm going to pick, this applies to any microservice, but I'm going to pick the example of you adding a new Lambda function to your serverless setup. And showing how you can use IAM and how we at Fraction 7 use IAM in the whole design process around that. So the first thing we do is we create a new unique role. And then we start mixing and matching single purpose policies to build up that role. So Many of you will probably have been in this screen here in IAM where you're creating a new role. So this could be, for any service. In my case, for my Lambda, I'm going to create a new role for this specific Lambda. And then I'm going to attach permissions policies to it. Now, what we do at Fraction 7 is, I don't know, hopefully you can see the bottom bit of that slide. We have lots of policies, and every policy we use a naming convention with. So we say the first bit is like the name of the project, in this case, community box, CB. DB means this is permission to do with database access. And then box contents is the name of the table. And then at the end, we have the thing this policy does. So we have CB, so community box, database, the box contents table, add, or delete, or get, or query, or read. And this is me just zooming out a step. Every single one of those policies is just one little paragraph there. It's just one tiny permission. So what we've done is we've gone from these huge, long, complicated permissions of the past, and we've gone down to a model of just one single permission each. So over time, we've built up a really large list of permissions, a list of policies. So when I'm creating a new Lambda function, I go in, chances are the policy is already there. And what I just do is I just search by keywords. In this case, I've just gone cb-db, and that's AWS has filled in for me all the policies that match that name. And I can just pick out. I literally just click on the bottom left. Okay, this function, I think it's going to need to get from that database table. Maybe it's going to need to update it as well. So it's really easy. All I do is I just create the role, type in cb-db because I want to look at database permissions for community box, and just point and click. And that way, I'm able to really quickly piece together a role. Oh, right, there we go. So another thing to note, it says no code there at the top of my slide. All of this stuff I'm doing before I've written any code at all. So if you're in maybe a business that's a little bit larger, like maybe a couple of employees, sometimes it can be useful before you actually write any code to say, well, what is this actually going to do? And if you probably already do this, you probably sit down and say, well, I'm going to write this Lambda function. It's going to do this, this, and this. Before I've written any code, I'm able to now sit down and compose these policies together. And this is really great, because at this point in time, we've not written anything. We're just still thinking. So even if you had a software architect in your business, you could task them with the role of even setting up these policies. And there you have it. At the end of this, we're going to have a role that you can hand over to a programmer, if your business is large enough, or if you are the programmer, you can start writing the code. But it's really, really clear. We've got there at the bottom our policies. I can see at a glance, just by looking at the role, what does this Lambda function do? Okay, it queries my box contents table, and it updates my box contents table. So this is great, because now as well, if I'm not quite familiar, maybe I have to debug or something, maybe on PagerDuty, I get called up in the middle of the night and say, oh, there's something happening with this Lambda function. I can just go into the role and just say, okay, well, what does this Lambda function do? So it gives us intelligence about the microservice. It straight away, you can look at it. That's another nice benefit we get from having lots of really simple policies that just build up into roles for microservices. And then my next slide here is quite simple, really, because now we write the code, okay, and then we test it. And now we start seeing three different benefits that come from this approach. The first one is, surprisingly often, you will have written the code, and when you test it, IAM will fall over. It will complain about some permission that your function doesn't have. And in the past, if you just use one of those kind of very broad, pre-baked policies that AWS provides for you, it will probably have worked. Because, yeah, all the policies would be there. But you don't learn anything. And remember that every time in AWS that some microservice accesses a resource, you are paying. You get billed. You get charged. So it's in your interest, in all of our interests, to know exactly what that, say, Lambda function in this case is going to access. And you'd be surprised how often you call some API call and you're convinced that this is just going to get an item from this database. Oh, actually, hang on a minute, it's doing a full scan. This is costing me. So rather than discovering that on the budget, when you look at your budget going over, instead, you'll discover it straight away. So you learn something. You learn something useful because you started with the most restrictive blank canvas and just added in exactly what you thought this function was going to do. And this is why I say kind of information about access patterns equals cash, because yeah, you're gonna pay if your function does more than you think it does. But the other one is that I mentioned in the previous slide about enforcing contracts. Now, as over time, this lambda function, in my example, is going to grow. You're going to add more functionality to it. You're going to add more things to it. IAM is always running. It is always running every single time you call that function. And that means you are safe. You have a safety net there that no matter what you add to that lambda function, IAM will fall over if that lambda function starts accessing resources in a way you hadn't expected when you first designed it. Again, if you start out with a really big reused policy from somewhere, you just wouldn't know. It would just work, but you discover on your budget when suddenly you go, hey, why is that costing so much? Okay, so layers. So probably most of you know about layers. If you don't, this is just an example of how AWS builds out functionality all the time, which is fantastic, but there is a danger with it as well. So in the case of Lambda, one of the cool things AWS added recently was this notion that if you have two Lambda functions and they share some code, you can pull that into a layer. And that's really useful because now I don't have to replicate the code between each Lambda function. I can just spin up a new Lambda function and say, oh, well, it uses this common functionality. I'll bring in a layer. And that's great. And to start with, it's wonderful. But of course, this brings back the really well-known problem in computer science of coupling. That now suddenly these two functions, these two services, rely on the same shared function. So you might have, when you first designed all this, you might say, well, each of these functions is going to do a get. It's going to get from a database table. And everything's fine. But then one day, and I'm sure a lot of us have been there, we go in to fix a problem in Lambda B. And go, for Lambda B to be able to do this thing it now needs to do, I need to change our shared function or shared layer so that it, can do this thing. And it needs to do, say, a scan of a database table to do that. So I go in and I'm really happy. Great, I fixed that. I've added that functionality into Lambda B, into the shared function. And now my Lambda B kind of gets this extra functionality. But of course, it's shared in a layer. So now our Lambda A function that we had never expected to be doing a scan, say, now it's suddenly doing a scan, simply because it's calling this shared function. Again, with IAM, if you use little building blocks and you build everything up from clean policies, IAM will complain the minute someone shares it into a layer and you update it. Now, some of you might be thinking, hey, we have continuous integration, we have tests, we have unit tests. And that's all good, but it's really difficult in a kind of continuous integration or unit testing to catch resource usage, to catch a function that's using an AWS resource in an unexpected way. So again, having unique IAM roles for every single microservice that you set up, all of them built up from the ground up, gives you that extra safety net. It gives you that extra control. Now, again, you might be thinking, hey, this is just an example that I've kind of put together for this kind of conference, and maybe it's a bit far-fetched, maybe it doesn't really affect us. But here's a slide I found on Amazon's website about some of their plans and how they see layers working. Right? So on the left there we have our Lambda, and in the middle we have our function code. But then the thing I've highlighted at the bottom right of the slide is it says partner and third-party layers. So Amazon is actually saying, hey, with these layers, not only can you share your own code, you can pull in third-party stuff from other people. And again, that removes the control we have over what that Lambda function is doing. Because if I'm pulling in some third-party API, I don't know what that does. I mean, they might not know what it does. I might even read their API documentation. It says, hey, if you call this thing, we'll do we'll use this microservice in this way. But do they? I mean, do they even know? So again, the more things go in this direction with Amazon Marketplace and you're suddenly pulling things in, on layers, you want to make sure that's not going to start costing you. So again, if right at the left-hand side there, your Lambda has very restrictive policies, it's good. I'm using Lambdas here because they're quite a good example. They're very flexible, they can do lots of things. But this applies with all the microservices. I mean, in the talk we had just before, in both of the talks we had before, we see this whole network, this whole family of microservices that all fit together. And Amazon's constantly adding in new flexibility, new ways for them to interoperate. So although I've used Lambda functions as an example, I'd encourage for any microservice, anything you set up, use this kind of approach. So kind of to recap where I've come from. So with an IAM-first approach, what I call an IAM-first approach, i.e., before you do anything, sets up an IAM role and set it up from scratch. We get free, remember IAM is free. You cannot get charged for it, as far as I know. Continuous enforcement of contracts between services. So you said, these two services are going to talk together in this way. IAM is going to be there for you if you set it up correctly from the start. And even if you build out your services in the future, IAM will continue to police it. I would argue the way I've presented, a way of doing it is an easy building block technique of building out the architecture. Have lots of single issue policies and just build them up like Lego blocks into unique roles. It leads to clean, easy to read policies. If there was a policy that wasn't there that I needed to kind of as a building block, it's not a big chore to have to go and write that policy because each policy is just a couple of lines. It only does one thing. So adding new policies is super easy. It's reduced risk of unexpected bills. I come back to this. You know, with AWS, we get charged for almost everything we do, so we need to make sure we have that safety net. And especially if you're a small company, you're a startup, you can't afford to have kind of a DevOps engineer whose sole job is to constantly monitor and monitor everything for you. You need every single bit of leverage that you can get. And IAM is a great piece of leverage for controlling and constraining what your services can do, built right into AWS. So a final thought to kind of go toward a slightly more blue sky finish maybe. For those of you who kind of come from a programming background, AWS in general, the whole of AWS in 2019 is a lot like where software in general was at in the 80s, where we see an application as a family of little services that all talk to each other, little processes, little objects, if you will, that talk to each other through messages. And in the 1980s, in software engineering, this was expressed through Smalltalk and Erlang. They kind of embodied those ideas. And two of the big advances in kind of software development since the 1980s has been emphasis on strong typing and access annotation. So access annotation is something like if any of you have written JavaScript or come near it, you know about the const keyword in ES6, or if you use C++, you know about that as well. But there are lots of other ways that in modern programming language you can say, hey, I'm going to access that file or that resource or that array in memory, and here's how I'm going to access it. I'm only going to read from it. I'm only going to read from it sequentially. And that enables, in the case of software, enables compilers to kind of do all kinds of enforcement for you and make sure your code is correct. IAM is a little bit like that, but for AWS. It's that thing where you say, look, I'm going to call this other Lambda function, or I'm going to access this machine learning service, and I'm going to do it in this way. And if you use IAM, IAM can be there to just help you constrain what your services are doing with each other. And that was a big help, a big leap forward in programming languages. Now, one thing we don't yet have is strong typing, as far as I kind of know. Strong typing for me would be to say, instead of saying, hey, this database, I'm going to write this number. It's me saying, hey, I'm going to write this number that is someone's salary. And it's making sure that at a later date, if I read back from another microservice and say, instead of saying, hey, I want this field and it's a number, instead I can say, this is a number that means someone's salary, and AWS will enforce that. So the way AWS is going is becoming more like a big distributed programming language. I wonder if maybe we will see that happening. But in the meantime, IAM policies can give you so many of the benefits that access annotation has given us in software development. So I think my time is up, or it's time for questions now. So I've got my question slide.
Great, thank you, Roland. Any questions?
With this kind of minimized idea that there's just like one policy maybe on an edge between like two objects, it almost seems like the idea of a role is becoming redundant, or have I misunderstood that?
Yeah, well, I think the role is still useful because the role is sort of what groups together the policies.
Yeah.
So you'd have, say I had two Lambda functions. I would have a role per Lambda function, and the role is then what sort of says that Lambda function is going to do this, this, and this. If you could, in the Lambda function, you can associate a role with the Lambda. If you could associate policies directly with the Lambda, which I'm not sure if you can, maybe you can, then you wouldn't need the role.
Right, that kind of ties in with something else I was thinking. I really like that idea that you put forward about almost like there's two objects, there's an edge between them, and the policy kind of aligns with that edge. But that's not how it is in the real world, so I find that kind of clunky, because you have to attach the policy to something, and you can't attach it to an edge.
That's kind of right, yeah. So that is kind of clunky, and it would be nice if that step was removed. But in the meantime, this is kind of at least part of the way towards that.
Thanks. I enjoyed the talk.
Yeah, no worries.
Cheers.
Thank you.
Okay, another question. Yep.
So when you're creating a role, you can attach permissions directly to the role instead of creating a policy. Is there any benefit to creating these fine-grained policies when you can just add the permissions individually, one by one?
So do you mean adding the permissions directly to the...
Yeah, so I think when you create a role, you can, for example, if you wanted to read from a Dynamodb table,
Yeah.
you can add that permission directly to the role.
Yeah.
Is there a reason why you would create a policy just with that Dynamodb permission?
I think for us, it kind of helps because, if I understand your kind of question correctly, for us, it's the fact that when I kind of create that role, I can get that kind of list of policies, just by searching, and I can just go, click, 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 and kind of add them to the roles. Just as that kind of point and click simplicity of it, as opposed to sort of authoring the policy directly, if that's what you mean.
Yeah, okay, thank you.
And possibly one more quick question. I see the value in having two people for this now. Really.
Hi. So when you have got really small policies, do you ever run into the limits of having, I think it's 10 per attaching? So, or do you use that as knowing when to split your lambda up?
Pretty much the latter. I mean, we hardly ever run into, because kind of we're super serverless, we're really serverless, so we just have lots of granular little things. So I guess we've never run into that, but that would be the point at which, you'd say, okay, hang on a minute, is this service doing more than it should?
Yeah, thanks.
Okay, great. So the break is happening now, so I think I'm going to have to call it a day for questions, but again, I'm sure Roland will be happy to take questions outside of this. Thank you very much.
Right, thank you.